So a lot of you probably look at different motors and you probably ask yourself, what does it mean? I spend so much time in testing different motors, studying where are like the sweet spots, so I'm happy to share my experience. First of all, you have to ask yourself, do you fly 4S or do you fly 6S? The future or the trend, as I've seen, goes definitely towards 6S. When I started with 6S, not a lot of people have used it, and now technical components will also go more and more towards 6S. So what's the difference? 4S, it's cheaper, the batteries are cheaper, the technical components, they don't have to don't have to be designed for like higher current. So of course, if you have like more power in a battery, the technical components also have to be designed to basically hold for that extra energy. So here in the front, you see different motors and they look the same, but they are very, very different, and explain. So first of all, like this motors, if we talk about 4S, that's a 4S motor. So on this, you can see written 2700 kV. So what does kV means? It's basically kilowatts. So it means with 1 volt, the motor spins 2700 times. So that what 2700 kV means. If you take a motor which has 1700 kV with 1 volt, it spins 1700 times. And you already can like make the connection. So when you fly 4S, you're going to have 14.8 volts, and you basically now multiply 14.8 times 2700 and you get 39,000 or like around 39,000 RPMs, round per minute. So that means the prop spins that fast. So if you, for example, use a motor which has 1700 kV and you combine it with a 4S battery, it means that you have 14 times 8, 1,700. So you're going to have less rounds per minute. So the prop doesn't spin that fast. That's why for motors with lower kVs, you're going to use a 6S battery. If you use a 6S battery and you take the motor which spins like 2,700, it's going to spin so fast. I mean, the drone is going to fly really fast, but you can easily also burn a motor. So if we look at 4S quads, you're going to usually have 2,700 kV as the higher benchmark, or you're going to have around 2,500 for like middle range, and then like 2,000, I would say like 400 at the lower range. Exactly. When you look at 6S batteries, you can literally have motors from 1,300 up to 2,150, for example, and that also depends like where you want to go with your quad. So I would say if you're a race drone pilot, you might want to go with 1,900 kV up to maybe 2,000, and that's already pretty high. Also 1,850 maybe. There you can also use basically a 5S battery, which is lighter than this one, but still has like a higher power than the 4S battery. Or when you want to do more like a long range cruise, more a cinematic, what I do, you're going to go with the 1,700 kV motors. So again, to summarize, if you want to fly 6S, you want to probably be below 2,000 kV. And there I tested different things. So you're going to have like, that's the, for example, the S motor, Mr. Steely branded, and this is like, oops, X-Nova motor, and you can also have like a massive difference there. So first, let's talk about long range. So if you want to go fly far, what I did is I have a 1,700 kV with a 6S battery, and I can fly 6-7 minutes, so pretty far, and it's also still enough powerful to do kind of some freestyle stuff. But of course, it's not as powerful if you have like a 1,850 kV motor. And then I don't have it here because I lost my drone. I had 1,600 kV, so 100 less kV for one of my drones, and I could fly almost 1 minute longer. It was a motor by Hobbywing, and I used it on my Super G frame, which I lost. But that was really great for most of my long range. But still, with that one from Xnova, I could do a lot of like long range stuff. So let's talk about another number. So sometimes you see, or like you mostly see 4 numbers on the motor, like 2207 or 2306. What does these numbers mean? So the first 2 numbers, the 22, 23, that defines basically the diameter of the motor. So if you have 22, it's like this size, and if you have 23, basically the stator it's going to be wider. And the last 2 digits, so 07, 08, that means the height of the motor. So if you, for example, have a motor like this one, 2207 means it's a little bit less in the diameter stator size, but it's also, and then 07, but it's a little bit higher. And then you have a motor like this one. You can also see it when you compare it to the side. This one is like 2306, so it's much, or a little bit wider and less high. Where are the benefits there? What I read or what I learned is that if the motor is wider and less high, you're going to have more torque in the low end. So if you do a punch, you can have more thrust on the lower end. And if you're going to have a higher motor, you get basically a higher thrust at the higher power. So probably most of the race motors are built to be higher. So that's the big difference. Okay, to have that said. Then when you look at the design of the motors, there is also a big difference. So for example, I took this one from Mr. Steel as an example. I hate this motor so much. And why do I hate it? First of all, if you put the prop on the top and you want to try like to make it hold, it's really hard because there's nothing on the surface which like a grip which holds the motor. Here on the Luminier, these are like the Johnny FPV motors. Used them like 1.5 years ago. They have kind of a grip there. So when you put the prop on and you make it tight, it actually starts, like it holds quite good compared to this one. And then like the best option is definitely like by Xnova. They have kind of like some sharp things like spikes. And if you make it hold, it's rock solid. And why is that important? If you're like fly far, or if you fly out and you hit the tree, with this ones, like the props like start spinning, and of course with the momentums of the drone, you will crash. Whereas this one, even if you hit something, it's because if these spikes, it just holds way better. In general, if you would ask me what motors should you go for, I personally prefer, and if I also look at what races fly, where the trend is of the pros, it's Xnova motors, or what we have on this one, the beautiful T-motor motor. And I would say first priority is for sure the Xnova motor. If you feel it, it's so smooth and it's really efficient. And even like when you crash, that thing just holds. Like a lot of crashes, a lot of bumps, and with these Mr. Steely motors, to be honest, I crashed once or twice, and I could already hear like the bearing, and it got loose so quickly. So when it comes to efficiency, I would highly recommend that Xnova motor, the 1700 kV version. And if you want to go with the more powerful, Xnova has like, I would say a lot of racers that fly Xnova's motors, and they're just like really, really fast if you go with the 1950 kV version. This T motors, you can also have them in different versions. That's now the 1700 kV version. So like the Savvy kV amount like here. For me personally, when I tested it, it used a little bit more power. It also has a little bit more power, I would say, but also a little bit less efficient. I mean, we talk about half a minute of flight time. So that's definitely the first priority. And yeah, think about the kV wisely. You want to have a niche, like if you want to go with 1300 kV, please keep in mind you're going to have less RPMs, so a little bit less power. So you want to have something which still has some power to do kind of like to also recover the drone, to have some power, but not too much that it becomes more racing oriented. Also, when it comes to prop, I will talk about propellers later on, but also keep in mind when you have a motor which has 2700 kV and you put like a 7-inch prop on, you're going to burn that motor pretty quick. So as a rough rule, I would say the lower you go with the kV, 1700, 1600, the bigger you can put on bigger props. So if you're planning to build a super long range, like super long range, a 7-inch quad, you probably want to have 1600 or 1700 or even 1300 kV motors, one of like these, and then you can like make much bigger props on the motor. But please keep in mind, the bigger the prop is, the more air you have to shuffle and the more amps, so the more power you need from the motor. So if you put too big props on, you actually gonna burn the motor or thing on the technical components. So when we also a number you should consider is like the 4 digits you see written on the motor. So when you see 2207, 2306, 2208, what do these numbers mean? So the first 2 digits, they define the diameter of the stator of the motor, and the last 2 digits, the height of the motor. So for example, when you have a motor 2207, that means the motor is less wide in stator size, I like the diameter, but it's a little bit higher. So when you take this motor here, it's 2306, that means it's wider, but it's less high. And what does that tell us? So when you look at the race motors, you can have 2208, so they're a little bit less wide in the diameter, means less, they're like more aerodynamic. And the higher the motor, I would say, the more thrust you have at the top end. So that's really important when you go racing. If you have like this a little bit wider stator and less height, you have more torque at lower end, which could be nice for freestyle to have that said. So keep that in mind. First 2 digits diameter and last 2 digits the height of the motor. Let's look at what else differentiates these different motors. If I look at this Johnny FPV motors, it's a little bit higher. You can have here a surface. It's nice when you make the props tight, it just holds. For example, this one by Ethics, Mr. Steele, it doesn't has this option, like you don't have like this surface which makes the prop like be stiff and hold when you hit something. And my absolutely favorite motor, highly recommended, is these X Novas. Like they're not super mainstream brand, but it's used by most of the racers. There is a reason for that. They have a spike on the top. It goes in the motor, and when you hit the tree, the prop, they just stay. It's not gonna like start spinning and you're gonna crash. And also, the motor is extremely durable. If you hit something, you don't just hear the bearing when you spin it, and they're also really efficient. I have this 1700 kV version, the smooth line by X Nova. I will put all these like my favorite drones and what do they mean in this description of this particular tutorial, and I just like it. So 1700, super smooth. I can still fly 7 minutes, but I would say almost on the same quality or preference is this T motor. It's the same kV, so also 1700. So also like a nice freestyle motor, and for me this one has a little bit more power, but is also a little bit less efficient. That's just when I have seen. When I could choose one, it would be an X Nova motor, 1700 kV. I've done great freestyle with that, and I could fly really far So that would be my go-to option if you haven't like bought a motor yet.